Well, now we're going to talk about HD 2019 1345C. Our HR 8832C is a hot, dense, rocky exoplanet orbiting around the K type star 219134 and the constellation Cassiopeia. Originally thought to be a little less than 3 times the mass of Earth, it is now known to be over 4.2 times the mass and 45% larger in radius, suggesting a rocky composition with a high quality of iron than Earth. The exoplanet is initially detected by the instrument Hertz north of the Italian telescope with the velocity while the transit of the planet were observed by the Spencer Space Telescope in 2017. Later that year, it was predicted that this planet has an exosphere. It's a rocky super Earth, meaning that it has a solid surface but is significantly larger than Earth. The mass of the planet is determined by to be around 4.23. Earth's mass was very low uncertainty. Its radius is 1.455 Earth radii, 9,300 kilometers. Once again, with a small air margin. The height being smaller in both methods than its sister planet, which we talked about. This works out to be higher at almost 7 grams per centimeter squared, heavily applying a rock and iron based composition similar to the terrestrial planets in the solar system. However, it appears to have a somewhat higher fraction of iron than Earth. The planet's gravitational pull at its surface is around 1.9 Gs, or over 90% greater than our Earth. Based on the planet's close proximity to its star, it is much hotter than Earth, which is about 62 times the influx of Earth. It has an influence temperature of 782 K, or 948 Fahrenheit, which is cooler than B, I'll tell you that much. About 400 degrees. I now some out certain metals. Depending on the greenhouse effect or the amount of cloud cover the planet's atmosphere, its actual temperature may be significantly higher. I mean, it could be double that. Its orbit orbits its star every 6.76 days to complete one full evidence of its orbital weight of 0.065 AU. For a comparison, the planet Mercury takes 88 days at 0.38 AUs. Um, so yeah, the star is point 0.8 solar masses and radius of 0.77 solar radii, 4,699 K, 11 billion years old. Its atmosphere is probably a secondary nature based on the composition of the planet and potential for atmospheric escape. The Physics atmosphere was calculated to reach a height of 0.13 Earth's radii, 830 kilometers below the predicted height of a hydrogen atmosphere. That this would indicate a secondary atmosphere produced by processes like volcanic activity and evaporation of volatile material. However, the composition of volatile materials could not be accurately determined yet. It is believed that this planet lacks the amount of volatiles of its sister planet and has an atmosphere more similar to the terrestrial planets of the solar system. This planet may have liquid water in its form, but it's too close to its host star, and so it would have experienced a runaway greenhouse effect and kind of Venus-like. I mean, this thing is probably most certainly Venus-like. It's absolute hell. It's probably twice as hot as Venus, but it's tied to locked. But with a thick enough atmosphere, I mean, this thing could be like Venus, have well, that's an equal temperature across the planet. Um, all I can say is absolute hell, just like its sister, which we talked about, which is Planet B.